Apple II forever. Making life better and better. Apple II forever and ever.
Thanks everybody for coming to KansasFest, and those of you online who are watching. Today I want to talk about further progress on my Apple II emulator. So this is a project that I started maybe 2 years ago, and it just kind of started out as a fun project, really a way for me to learn JavaScript and TypeScript. And I'd always wanted to also write an Apple II emulator, and so I thought, well, why not just combine those two projects? And so I didn't really have any ideas other than that. And then last year when I presented it, there were some people who gave me feedback, including Mark Lambert, who said, well, what about debugging? And what about this and that? And so I've spent the last year kind of enhancing it. It's still really, I don't have like a particular end goal. It's all open source. It's out on GitHub. I'll have the link at the end. So I also welcome people if you want to contribute to it. I've already had a couple people who've done pull requests, and also lots of people who've logged issues as well. And feel free to stop me during the talk if you have questions. So what is it? It is a Apple IIe enhanced. It has anywhere between 128K of memory up to 8 meg. That's user selectable. It has a floppy drive built into it, and also supports SmartPort and ProDOS block drivers as well. As I mentioned, it's written in TypeScript and React.js. And it, at least right now, it's client-side only, so you don't need to have a web server installed. It doesn't require a web server anywhere, so it just runs in your browser, works on pretty much any browser and platform, including Mac, PC, phone, tablet. Although somebody who pointed out to me, your mileage may vary with tablets, depending on the screen size. I haven't fully optimized it for all different sizes of tablets and phones and everything. You can see a list there of all the different file formats that it supports, so it's pretty much anything that you can download from the web. You should be able to read into it. And then I also have a custom save and restore format. So if you're in the middle of a game or a program, you can just hit save state and it'll save it off. It'll download the file to your own computer, and then you can just reload that back into the emulator and pick up right where you left off. So GitHub, I already mentioned. Actually, that's also where it's deployed. So it actually runs off of GitHub Pages, which is just a really simple way to deploy web applications. And finally, it's also deployable as a progressive web app. And so you may know I think it's usually in Chrome, maybe Safari, there's a button typically in the upper right, and you can say download this web page as an application, and it'll just show up on your desktop as an icon, and it just works more or less like a real application. In fact, you can even associate file suffixes with it. So you could say, instead of that old Virtual 2 emulator, you could associate your disk images with my emulator instead. And I'm joking. I have to admit, I still use Virtual 2 every day. I have not actually changed my computer to actually use my emulator if I double click, so don't tell the author. Virtual 2 is amazing. So I'm not going to go into the architecture. I talked about this last year, but for those of you who are curious, it's actually split up into two pieces. So there's the main thread, or whatever you want to call it, process that is running the front end. So that's the GUI, the graphical user interface. And then I have a completely separate, what's called a worker thread, and that's running the actual 6502 emulator. And so this allows the emulator itself to run at 1 megahertz exactly, and it won't interfere with the updates on the actual GUI. And I'm happy to talk about that offline if you're curious. So Forrest, go ahead.
Question, I apologize. Do you interpolate the long cycles also?
Do I interpolate the long? Oh, yes. So Forrest is asking if I interpolate or emulate the long cycles on the 6502. So some of you may know that the 6502, it runs at 1 megahertz, but not really. Sometime, every now and then, I think it's every 65 cycles or something, or there's like a slightly longer cycle. You know, it's just a tiny bit longer.
It's to synchronize the videos.
Yes, and it's for the video. I do not emulate that. I also don't do a good job at like vertical blanking, and so if you're trying to run something like the French Touch, they're super fancy videos. Some of them will work in my emulator and some of them will not. That would certainly be an area if somebody wanted to contribute code. I would be more than welcome. See, it's so easy when you're open source because you can be like, oh, that's just left as an exercise for the user. So, Tom. Yeah. Yes. So Tom is pointing out that on the Apple II, it's actually it's not just 1 megahertz. It's 1.023 something, and mine gets very close to that. It's not perfect. So last year I showed the sound effects from the Apple II. So you know, the Apple II has a 1-bit speaker, which means it's just a click on and off. And I was able to get it working last year where it sounded okay for simple sounds, you know, if you were just playing like a normal 8-bit game. But if you were trying to do something, for example, Nox Archaeist, where it uses pulse width modulation for its initial sounds on startup, and there's a few other games that do that where they're actually they're driving the speaker way faster than possibly the human ear can actually hear it. But when you do that, you can kind of do these overtones and it turns into actual like speech. So you can actually make the computer talk. And this is something that I just could not get to work, at least last year. And the reason why is because on a modern computer, they can only typically drive the speaker or the sound up to 44 kilohertz, which is like a CD-ROM. That's all you really need because our ears don't hear anything above, you know, well, in fact, our ears probably only hear up to maybe 15K now, but it's way beyond human hearing. And so they don't need to do that. And this is actually a problem. The Apple II is actually way faster than a modern computer for audio. And so I went online. Yeah, good. Yay for Apple II. So I went online and there were some people who had some really great suggestions. Kent Dickey, who's like an expert at Apple II sound, he gave me some pointers on how to do that. And we'll hopefully be able to hear that later. But anyway, the short answer is I got all that working. And now, for example, Nox Archaeist, when you start it up, it actually sounds great. So that is an improvement. Mockingbird. So this is something that I had no idea how to do, and I was scared, and it was like terrifying to me. The problem with the Mockingbird is if you go out online and you get like the user manual for the Mockingbird, the one that tells you, like, say, how to actually write Mockingbird sounds, this gives you no information on how to actually create the Mockingbird sounds from like an emulator point of view, or if you were actually going to try to create like a replica of the Mockingbird card. The trick, which somebody said, was like, well, you just have to go back to the data sheets for the actual chips that are on the Mockingbird card. And that was the key. So the Mockingbird, it has 4 chips on it. There's 2 chips that are these 6522 VIA chips. So it's a versatile interface adapter made by the same company that actually makes the 6502. And those are the ones that basically communicate the signals from the Apple II to these 2 sound chips. So these are the AY3, you know, the number doesn't matter, it's the AY38910. That's the actual chip that constructs the sounds for the Mockingbird itself. And those 2 chips talk to each other and basically translate these signals from the Apple II or the codes into the actual sounds that you're trying to play. And so, you know, I just had to study the data sheets, read through them all, and then just implement it like completely kind of from scratch. Just to give you an idea of kind of the complexity of the Mockingbird signal, and you don't need to, well, there will be no quiz on this, let's just put it that way. So on the left-hand side are the 8-bit register, or the registers that you need to set to construct Mockingbird sounds. And so you'll typically say, I want to turn on channel A, and I want to have it have this volume, or I want to use the noise. And so I don't know if any of you have played around with the Mockingbird where it can do like sound effects, like a gunshot or a helicopter or something like that. And so they have all these little sound registers that you have to set, and you have to get all those correct. And then actually the most fun part about this project was the way the mocking board works. You can actually set like an envelope for the sound. And so you can imagine like a sound, like just a single tone, like a middle C or something like that. But you can actually modulate that with these envelopes where you can say, have it go low up to high and then back down to low and then up to high. And so you can see there's all these different waves and the shapes of the waves. And so that was actually a lot of fun to figure out, how do I write that in TypeScript using web audio and have it actually sound like the Mockingboard. And I'll demo that in a few minutes. Any questions about that? Yes?
Well, I just wanted to thank you on project partner on behalf. He got our sound working by looking at your code.
Ha! Okay, well, I'm glad to hear that. Excellent. Yes. Did that. I'm glad he could be of service. So, all right, so I mentioned before about contributions from the community. So Mike Morrison, who also turns out lives fairly close to me in Colorado, he contacted me one day and he's like, hey, I'd really like to add support for a MIDI card to your emulator. And so I was like, that sounds great to me. And so he wrote the code and just did a pull request for it. And it's amazing, right? You can, Apple II, you could hook it up to a synthesizer, so like a real, keyboard, where you could play musical notes. And there were cards back in the day and solutions for actually hooking an Apple II up to a MIDI sound system. And so that's what he replicated then in the emulator. And if the sound all works properly, I will demo that as well. And then he also he's like the master of peripherals. So he also added support for the mouse. So the Apple II mouse card. And so you could use mouse paint if you wanted to in the emulator. And then the coolest thing, which he actually just did, is he added support for the Super Serial card and specifically printing to an image writer. And so I had a printer before in the emulator that he had worked on, and it was just sort of like a virtual printer where it would just spit out a PDF. But he just got it working where you can actually connect your modern computer to an old image writer and actually print from the computer to an image writer. And I bought the cable and I had it specially shipped to KansasFest because I was thinking, surely someone will not listen to what we say. They will bring an image writer to the garage giveaway. It will just sit there and we'll have to throw it away. But no one brought an image writer. So I can't demo it, but trust me, it works. It's beautiful. So it's actually, I don't know, it's kind of fun to, even though, of course, back in the day, printing to an image writer was not a big deal at all, it's just very cool to hook up a modern computer to, an old piece of equipment. Yes, Forrest.
Last year, there were like 4 of them.
I know, they were all there last year. I know, and then we didn't know what to do with them. Well, this actually is serial, right? It's RS-232. So this is 8 pins, not 25 pins, so unfortunately, it's not going to work. Anyway, it's something if you want to try it out at home, you're welcome. So I talked about this last year. One of the cool things about writing an emulator is you can kind of do things under the hood that the Apple II wouldn't be able to do because you're in complete control. And so I had this way to hook in custom handlers. And so if you're playing a game, I know which game you're playing, and then I can do things like add extra key controls, support for the joystick if you want, or just put up extra help on the side of the screen. And this is just a list of all the games that it currently supports. This is definitely an area where if people wanted to contribute more games to this list, it's easy to do. It's just a single file that you need to say, like basically, how do you detect which game is playing? And it's really simple to do. So if you have your favorite game that you don't see on this list, feel free to add to it. Mark?
So I see over the Knox repairs, gamepad is joystick support. I didn't know Knox repairs had gamepad joystick support. How did you pull that off?
Yes.
Do you have some kind of a translation player in there?
If that Knox Arcade game just didn't have so many keys, would have made my life a lot simpler. So yeah, and same thing for Ultima. You could do the same thing. So basically, for Nox Archaeist, it detects the game, and then if you're using a gamepad, so something with like 20 or 30 buttons that I can't ever seem to actually really use that well, what it will do is, let's say you move the gamepad control to the right, it will just send a right arrow key to the game. Or if you press the A button, it will send, say, the attack or the camp key or whatever key the game expects. When you press the button on the gamepad controller, that's the key it will send to the game. And that was exactly how he did Aztec as well. So as you may know, Aztec, the shirt here, it's notorious for its keyboard controls. There's like 20 different keys you got to do, and it's a mess. But actually with the gamepad, it's kind of fun to play, right? You can run around, you can pick up the little, explosives and put them down. So yeah, so try that out. It's a lot of fun. All right, so finally we get to debugging. There's a big list here of things. I'm actually going to try and demo a fair number of these in a few minutes. But this is kind of what I really wanted to get to this year. And so I've tried to add as many features as I can imagine a developer of 6502 software would need. Some of these came from actually Cucumba or Peter Furry, who is a crack 6502 developer. He worked on Nox Archaeist. He's worked on Total Replay. He's like the master of 6502. And there were some of these features that he's like, yeah, could I please have that? Could I have this? So you can set breakpoints. And the breakpoints can have conditional expressions, hit counts, etc. You can set watch points, so you can say when a certain memory location changes or even is looked at, then stop the program, stop the 6502 and show where you are. And then you can break on a particular instruction. So if you're looking for like something unusual, like a clear interrupt CLI or something like that, you can say, okay, stop when you hit that particular instruction. And then there's some other features which I will demo in a couple minutes. Any questions on any of that? All right, yes, Mark.
Time travel. I noticed that wasn't on the list, but I know you did some work on that.
Yes.
Unless that was to come, I was curious.
It's just
One of the many features, couldn't even make the list of that. No, yes, that's a good point. I'll point that out. So let me fire it up. So actually, I'll just wanted to real quick show you. So this is just Visual Studio Code, which is what I typically use for coding. The nice thing about using something like JavaScript or TypeScript is you kind of get instant feedback. So there's no real compiling. And just to demonstrate, so I'm using npm here to run everything. So if I just do npm start, it's running. So that was it, right? It just instantly comes up. If I make changes to the code, it will just automatically refresh the page. So you can kind of, just see if you make a tweak to the way it looks, it's going to come up instantly. But let me actually run it. I just wanted to show how quickly it came up. I'm actually going to run it over here on. So the website itself is apple2ts.com. So that's where you would go to actually run it yourself. And let me fire up. So I don't want to go through all the features. You can kind of play with it. There's a bunch of controls. You can see down on the bottom, hopefully my mouse will show up. There's 2 hard drives and 2 floppy drives. This is all kind of hard-coded right now, so you can't really change slots or add new devices. Maybe that's something that someone would like to contribute. And then we also have a bunch of built-in disk images. So these are it's mostly things that I like. So if you have your own favorite thing, you can put it up there. But I'm a big fan of Olympic Decathlon, which is kind of a maybe slightly obscure title. But my kids actually used to love playing that when they were younger because it's such a goofy game. I have Total Replay in there. And so, if you just click on that, it will, actually now it's downloading it from the internet. There we go. So there's Total Replay. It comes up, and then you could just pick your, let's do my old standby here, Karateka in honor of Jordan Mechner. And then you can see over on the right-hand side, it recognized that this is indeed Karateka, and it put in some help for you. And of course, if I switch to it, there's a button to go full screen where you just see the game itself. You wouldn't see the help. But if you're new to it or you don't remember the controls, that can help. So let's start the game. You think? Okay, there we go. Yeah. Yay. Okay. Now I'm echoing. Okay, that's fine. So, okay, so there's Karateka. Wow, this is like being in a... Let's look at the Mockingboard support. So I'll do activate, one Mockingboard. It's Mockingboard A, slot number 4. Okay, so there's Mockingboard. Cool, cool. Okay. All right, now let's return to the view. Okay. Let me switch now to Aztec. Oh, wait, hold on. Let me refresh it, because otherwise the Mockingboard will keep playing. All right, do you want to turn off the sound? And then I don't echo. All right. Okay, so let's just take a look at some of the debugging features. And I figure Aztec is maybe a good game to do that with. It has some pretty graphics. Let's actually just start the game. And you can see on the right-hand side, it told you all the help, and it even tells you if you do have a gamepad hooked up to your laptop, it'll let you use the gamepad for this. And the emulator, it's just using whatever the web interface is for game controllers, and so you can pretty much use like an Xbox controller or a Sega or just a kind of a generic game controller, or you can use one of the Bluetooth controllers from that Mike Mendelson has created, and those just work with the web browser, and then my emulator should be able to recognize it. So if I want to switch to the debug view, I just hit this little toggle debug, and so now we're in the debug view, and it might be a little small from the back of the room, but basically there's kind of a few different sections on here. On the right-hand side is kind of the main, this is what the 6502 is doing, and so you can see there's a stack trace or a stack dump there. There's a map of the memory, and it tells you whether the memory is coming from main memory or auxiliary memory, so it'll highlight it if it's from an auxiliary memory. Mark mentioned time travel, and so down on the right-hand side, we can see there's a list of time travel snapshots. I'm not going to click on it because I don't want to mess up the graphics, but basically if I click on one of those, it'll actually go back in time to a previous state of the emulator, completely restore that state, and let you pick up where you left off. And I haven't fully figured out when to do snapshots, and so if anybody has any thoughts about that or wants to contribute, right now I'm just doing it every keystroke that you make, it saves a brand new snapshot, because I was thinking if you're playing a game, typically you're hitting some key that's doing something, and let's say you're playing Aztec and you get killed, probably you did something that involved the keyboard and you want to go back a few steps to when you're still alive. But this can get expensive, because if there's disk changes, it has to save the entire state, including the disk state at that time. And so, there's probably ways to optimize that. So let's see what we can do here in the debugger. So I can add breakpoints here, but I can also just stop the emulator. And so you can see here's this is where I stopped in the code. So this is all the 6502 assembly. I can add a breakpoint by just clicking there, and then if I hit that instruction again when I'm running, it'll actually stop at that breakpoint. And then there's also a place, let me see if I can make it bigger and not, yeah, that's maybe better. I can also just add breakpoints this way, and so if I click the plus button there, here's the different types of breakpoints I can add. So I can add a breakpoint, and I could say something like, let's say if it hits C800, and you can say something like if the accumulator is equal to accumulator equal to number string F0. So if I hit that address, C800, at the same time that the accumulator is equal to, say, F0, then stop. And so this allows you to kind of do things like, well, you know there's a breakpoint, or you know you want to stop at a certain line of code, but maybe it hits that line of code like hundreds and hundreds of times, and you only want to stop when something else is true, then that lets you do that. And then you can do things like, you know, I want to only break when I've hit that, when I've reached those conditions 5 times or something like that. On the 5th time, then break. So that's the type of thing you can do. And this will never get hit because I don't know what the heck C800 is. I mentioned about watch points, and so these are memory locations. And so I have a list of built-in ones. So these are actually all of the standard things like keyboard strobe, or basically soft switches. So you can say stop when somebody toggles to auxiliary memory or something like that. Or you can put in whatever address you want. So you could say, you know, if somebody changes address 400, then I want to stop at that instant. And so we can put a breakpoint for that. And then finally, there's these instruction breakpoints. And so I have all of the different opcodes or instructions that the 6502 understands. And you can tell it break, say, for example, when I hit the BCS instruction or something. And then it actually, you can tell it, you know, which addressing mode that you want to stop at. So that's that. And let me kill these just so. Other features, I have a way to look at all of the memory in the 6502. So this is the memory dump here. And so you can, there's a pull down here. So you can scroll through. Let me make my window a little bit bigger. There we go. So you can see on the left-hand side, that's all the hex values for the memory. And then the right-hand side, that's an ASCII representation of those values. And so you could actually look for, let's see if we search for the word Aztec. So you can see the word Aztec is there, and that's the hex values, and it tells you where it is in memory, and it highlights it. And then you can change which part of memory you're looking at. So right now I'm just looking at what the Apple II state is in terms of its current memory. You can also say, well, I only want to look at main RAM. And so this will look at all the memory from 0 up to 65535. You can look at auxiliary RAM if you know that you're using that part of memory and you have some value up there. And then finally, one of my fun features is you can say, I only want to look at the high-res graphics memory area. So page 1 of high-res graphics. And once you do that, then you get the magnifier mode. So, thank you. Yeah, so this mode, in this mode, you have a little cursor, you can move it around, and then if I click, it'll actually highlight that in memory. And you'll notice that those of you who have played around with high-res graphics memory know these addresses should not be in order, right? They jump all over the place. It's basically like you have a line of graphics, and then the next line on the screen is actually, 400 hex, addresses later on or something like that. It's a mess. But what I've done here is I've actually organized the right-hand side by the way it's mapped out on the screen. So it's mapped in screen order as opposed to memory order. So if we actually go back up to the top of this table, you can see I'm looking at address 2000 there in memory, and then the next address in here is 2400 because that corresponds to the line in the graphics screen, if that makes sense. So it's just a way to make it easier to map from addresses to screen. And then you can also go the other way. So if I go over here and I click, then it actually just shows me what I'm looking at in the screen. And then I can change values too. So if I go in here, I can make this like a FF and I could just start messing around with, the way it looks and completely screw up the way the game looks. So hopefully this is useful if you're trying to debug graphics and figure out, okay, well, what hex value, why is it there, and it should be somewhere else in the memory, or why is my graphics just look so strange? So Mark, thumbs up?
Awesome. Yeah, and I mean, everything up to this point, I think we had talked about. I didn't know that you did this with the graphics. That's so bonus. This is amazing. This is amazing. We got to show this to Michael Korosky, the Apple I developer. He would absolutely love it.
But don't do that because Apple Win is still better than mine, and then he'll just put it in, and then I'll still be behind, you know. So just keep it as a sleeper feature. So.
I wasn't even thinking of competitive.
No. I'm just joking too. Yeah, there's no competition. Yes, that is very true. Yep. Okay. Any questions about any of this? Obviously. Oh, yeah. Go ahead.
I was looking at memory configuration. I got a little confused. The memory configuration says 64K aux play. Does that mean it's total company change, or does that mean it's total 64?
So this memory map here on the right. Oh, right. So this one right there. Yeah. Okay. So what we're talking about here is this is the amount of extra memory that you're adding to the computer, and so it's not including the base 64, the original 64. So the default is to add 64K of memory, which would just be like the auxiliary card, but you could just change it to up to 8 meg if you wanted to.
Are you able to emulate just the 80 column card without the aux memory?
No. But someone could do that if they wanted to. No. Anyway, yeah. Oh, sorry. The question was, am I able to emulate just the 80 column card, so without the auxiliary memory? And no. Forrest.
How are you addressing all that extra all the time about engineering?
So the question is, how am I addressing all that extra memory? Yes. So it's using the standard applied engineering protocol. I tested it with, as many programs as I could think of that actually, there's very few programs that can actually use 8 meg. Apple Works would be one. Some disk copy programs can actually make use of it. Typically for what I'm doing, which is mostly games, I don't ever even change it, but it was more like a user requested that, and so I just added support for that. Okay. All right. There's a lot of other things that I didn't cover. I strongly urge you to go and try it, play around with it, find bugs. I actually did find a bug with the time travel just a few minutes ago, where it would if you eject the disk, then it gets horribly confused and it won't let you go back to the previous state. So that's there are bugs, shockingly, as in all code. So let me just jump back here. I just have a couple more slides real quick. So some thanks to all the people that have helped with the development over the last couple of years. Future work. So it'd be great to add more support for other peripheral devices. If there's something that you think should be in here, that'd be really cool. One thing I really want to get going is being able to save the state. So not save it off to desktop, but like if you close your laptop and come back, it will remember typically, but if you close your browser, right, and reopen your browser, then it's going to lose your state. Mark and I have talked about this as maybe an alternative way to run, say, Nox Archaist, and obviously we don't want people to lose the state of their game. So I'm thinking about, maybe I should actually save the state in the browser cache and then just be able to restore it that way. And so you can pick up right where you left off, even if you close your browser. And then maybe there's ideas for networking. Obviously, I'm already talking to the web, so what about multiplayer games or something? I haven't even thought about that other than that one sentence. So let's see. Here's the final information. So that's where to go to to work with the emulator. That's the GitHub. This is all out on my website as well, so if you don't have to write these down. And there's an email address if you want to contact me directly. Questions? Yes, Mark.
So back on the screen where you have the graphics and the name on the left, is it possible to switch between Fire State 1 and 2?
Yes. So Mark's question is, if you're in here in this fancy pants HDR mode, you can switch to, so here's page 1, or you can switch to page 2. And as you can see, Aztec does not use page 2 because it's just filled with garbage. but there actually are plenty of games that use page 1 of high-res graphics and page 2, and then they just flip them back and forth really quickly to animate things.
But it either doesn't use it or just a copy of the graphics screen from Castle open side and throw the grenade against the wall.
Oh, and it destroyed the entire screen. Yes, yes. I think Nox Archaist actually uses both pages, right? So that would be an example where you could actually take a look at it, and you would actually be able to see the difference.
Do all the time, graphics program side and see what's going on.
Right, and you can see that the little magnifier actually remembered where it was, and so you can kind of quickly flip back and forth and, you know, see the differences. Good question. Other questions? Yeah, Jay.
Does your emulator support copy paste yet? Text pages and the feature you consider adding?
Yeah, so the question is, does it support copy paste for the text pages? So yes, it has a there's a copy button, and I think actually just like Control C or Command C, it will either, if you're in text mode, it will copy whatever's in the text page on the screen, you know, in the Apple memory. If you're in a graphics mode, it'll actually do a screen scrape or a screen capture of the high-res graphics screen. Yeah, does that answer your? Okay, so if you paste, you can, if you paste, it will just paste it in just as if you typed it. And so if you had an AppleSoft program, you could just copy it from wherever and then just paste it into the emulator, and it would just spew it out, and then you could run it. Yeah. So I think the question is, if you had something on the 2GS that was using like a ProDOS program, as long as it will run on the Apple IIe, it should also work in here as well. This does not emulate, though, an Apple II GS. So if you had something that was a specific, you know, like Rastan, can't run Rastan, don't ask. I'm not going to do it. I don't think I'm going to do it. I'm pretty sure I'm not going to do it. I don't really know anything about the 2GS, so yes. That's, yeah. Forrest.
On your disassembly,
Yes.
is there an option for giving you cycle counts?
Is there an option for giving the cycle counts in the disassembly? There is not. That's kind of a cool idea, though. I like that idea. Yeah, I mean, I have the total cycle counts over on the right, but that is kind of a meaningless number that, yeah, you can't really do much with. So I like that.
That's useful to play like Death
Yeah.
I'm never calling it the total cycle count on the save screen.
Yes, that is a cool idea. Yes, okay, I'll think about that. Mark.
I see that some of the memory addresses in this assembly are blue. Does that mean that if you click on that memory address, like in the branch statements, whatever, it'll actually take you to that part of memory?
You mean like that? I swear I did not pay him to ask that question. I completely forgot. Yes, so those are all hyperlinks. Oh, and I should point out, so it actually, thank you. If you hover over the number on the right-hand side, it'll actually tell you what, in this case, that's just a hex, yeah. Let me see, there should be, yeah, okay, so here, this is just a number, like what do you call it, an immediate number, or what am I trying to say? It's just a hex 17, and that tells you that's actually immediate mode. That's actually a 23 in decimal, and it even gives you the bits in, so the binary. Just, I didn't know what else to do for immediate mode. I'm trying to find, there's one, oh, here we go. So this is, yes. So this is an indirect address mode. So you can see that LDY, it might be hard to see from the back. So it's a load from the, load the Y register with a value, and it's got a comma X, which means it's going to use the offset of the X register. And so this is called indirect addressing. And so if you hover over that, the little tooltip tells you the address is 0, the X is currently 22, and therefore that's the address that it's actually going to load from, and then it tells you the value that it actually is going to load. So it kind of helps. Yeah. Cool. Other questions? Okay, well, feel free to come grab me afterward. Also, feel free to contribute to the project. I'm happy to entertain pull requests and help. And yeah, thank you. Okay, here I am for questions. One thing I was trying to pay attention to the Discord, and so I wasn't actually paying attention to my talk. I don't know if I mentioned about hovering over variables in the on the right-hand side of the disassembly. I think Mark pointed out that there were some blue. There's the addresses have little blue hyperlinks on them, and if you hover over those, it will actually it's a hyperlink to that section of code. So if it's say a jump, a JSR, you click on it, it'll jump to whatever that location is, and then if it's just like a simple address, like a LDA or something, and you hover over the number, it will tell you what the number is, or if it's like an indirect address, it will actually do the math for you, and it'll put up a little tooltip with the actual address. And so it does that during debugging. But I didn't show that during the actual talk, I don't think. So let's see some questions that came in. Somebody asked about way back during KansasFest, they asked about mouse text, and you can, if you click copy when you have the emulator up, it will either copy the text screen as just, it'll just put it onto the system clipboard as text. So you could paste it into some other application. If it's actually graphics that's on the screen, then it will just copy it as a bitmap image with the same resolution as the Apple II screen. But if you copy mouse text, it will just copy it as regular ASCII characters. So it doesn't know anything about mouse text. And I'm thinking about changing that so it actually copies it as Unicode characters, because mouse text actually has been mapped over to Unicode. And then, you know, if you had the correct font on your Windows or Mac and you pasted that into another application, then it would actually work correctly. Let's see, Quinn was curious about how ProDOS disk images work, because she noticed that it's actually not loading ProDOS images into the regular disk drive. And what it's doing instead is it's loading them as a block disk image. So just like as if it was a hard drive disk image. And the only reason I did that was for speed. So you can treat any ProDOS disk image .po, whether it's, you know, 140K or 32 meg, you can just treat that as if it was a hard drive disk image. And so it just loads significantly faster into the emulator, because it doesn't have to do it byte by byte or bit by bit like a regular disk. There's no way to turn off that feature right now. Maybe I should have a way, you know, maybe depending on which disk you actually click on to load the drive, then it should just do what you think it should do. Let's see. I think Eric asked about mouse support. So it does emulate a mouse card, and this is stuff that Mike Morrison did. And so, yeah, it'll emulate just a standard mouse card, and so you can use things like mouse paint. You know, one thing that I haven't really thought about much is actually peripheral cards and where they should go. Everything is hard coded right now, so you know, mouse card is in slot 2, I think. Maybe I might get that wrong. You know, Mockingboard is in slot 4. You know, the printer's in slot 1, and you know, you can't change any of that. So, you know, I kind of started out, you know, I originally started out as an Apple II Plus, and then I made it an Apple IIe. There's no way to go back to a 2 Plus. So that's an area where, you know, I should probably make it a little bit more configurable, where, you know, where you can say which card is in which slot and take them in and out, etc. Let's see, there was another question about, am I using any WebAssembly? And I've thought about that several times, and I even started to go down that path. But realistically, for what I'm doing, I never really needed the speed increase that you might get from WebAssembly. It just seemed like no matter kind of what I threw at JavaScript, it was able to handle it, you know, in terms, you know, it could always run at 1 megahertz. And I think, you know, maybe if I changed part of it to WebAssembly, I could increase the speed, especially for like the fast mode. So there's a button where you can say, run it as fast as possible. And right now, I think it tops out at only like 5 megahertz. So maybe if I converted it, part of it to WebAssembly, that might, make that better. But for now, I just haven't needed to do it. And so I haven't bothered to, go down that path. I see there was another question about FujiNet support. I think you could probably do anything like that. Same thing like the Ethernet card. It's just, a mere matter of, having the correct drivers. And so we actually, we have like a super serial card driver in there, and that's how the printer works, as well as the, I think, does the MIDI card also use that? So I think all the pieces are there. It's really more just, somebody just needs to go in and think about wiring it up. And, same thing with the trying to do, like play games over the web, like using that web RTC. It's just, somebody just needs to write the drivers for it. So yeah, anything else anybody has? Otherwise, we can just move on. Great. Thanks, everybody.